Hi, I'm Wayne Leck and this is question 10 of June 2013, AQA Core 3. It's the final question, and according to my examiner's report, it's a bit mix and match. They tried to end on a hard question, of course, quite a lot of marks up for grabs, and it's tricky integration stuff. So, without further ado, let's go to the whiteboard and go through question 10. So, question 10. There's A, part 1 and 2, and then there'll be B on another board, and that's going to take up a bit more room, so I'm doing it on another board. So 10A, part 1. By writing natural log of x as natural log of x times 1, use integration by parts to find the integral of ln x. So it sort of told you in the question what it wants you to do. Straight away, it wants you to treat it as ln x times 1 dx. That's a times. And so that's what we're dealing with. Now it seems silly to say that's times by 1, but that's what it wants us to do. Use integration by parts. Now that is in your formula booklet. When you're integrating it, we treat it as u dv dx, that we're actually integrating by dx. So we're integrating u dv dx. So the formula for it is uv minus the integral of v du dx by dx. Okay, so that's the formula for working it out with integration by parts. So you need to say what's what before doing it. So u is our ln x, our natural log of x, and v is our 1, it wants us to have a 1. So du by dx, you should now differentiate ln x, it's just 1 over x. And, that's dv by dx. So our v is x. So now we can go to our formula. uv is ln x times x, which is x ln x. Then we've got minus the integral, so we'll do it over at the side here. We've got the integral of v, which is x, times du dx, which is 1 over x dx, which is the integral of 1 by dx, which you should know is just x. So it's x ln x minus x plus c. That's our final answer. Now I might have been a little bit confusing there because I wrote that as v and then changed it to dv dx. Because of this formula, it's the product rule, it's u times dv dx. So if ln x is our u, and that means dv dx must be our 1, and I put v by accident. So you've got to differentiate u to get du dx, and then integrate dv dx to get your v, and then apply it to this formula. And so that's your final answer, x ln x minus x plus c. Part 2, find the integral of ln x squared dx. Now, with these sorts of questions, you can see quite clearly that that's quite similar to part 1. They're in part 1 and part 2 rather than A and B. The chances that they're completely unrelated is very slim. So it's a good shout to think, well, what they want you to do is ln x squared times 1 again. Okay, if it was part A, if it was A and then B, it's perhaps less likely that they're going to be tied together, although still it's going to be some sort of tie probably. But when it's part 1 and part 2, they're almost certainly tied together. So without telling you this time, it wants you to times it by 1. So we're going to use the same formula again. So we need to select our u. Let's say it's ln x squared. And our dv by dx, this time I won't put v and then change it. dv by dx is 1. So our du by dx, we're now differentiating ln x squared, this is what some people troubled with, is 2 ln x 1 over x, which you can write as 2 over x ln x. That's another format for it, it's just rearranging it. So it's 2 ln x 1 over x, and then we've got to integrate this again to get our v, and it's the same as before, it just becomes an x. Integrating 1 becomes an x. Then again we can apply our formula, so we've got uv, that's our first bit, u times v is x ln x squared. Then we've got minus and this time we've got the integral of v, which is x, times du by dx, which is our 2 over x ln x. So if we were to expand that out, we get 2x over x ln x, so the x's would cancel out and become 2 ln x. Now, in this question, we've integrated already ln x. That whole thing, this whole answer here, was an answer to ln x. When we did ln x times 1, but that is just ln x. Now in this case, we're integrating 2 ln x by dx. So we're going to be using this. It's going to be 2 lots of this. So it's going to be minus 2 lots of x ln x minus x. Then the whole thing will have a plus c. So I'll write that a little bit clearer on the line below. I'll do it again a bit. So we've got the start, we know how we do that, it's just uv, x ln x squared, that part's fine. Minus, so this becomes 2 ln x, it's 2 lots of what we integrated in the first place, so it's 2 lots of x ln x minus x. And then we have a plus c, again you need the plus c. So in terms of marks, part 1 was 4 marks, part 2 was 4 marks, that's 8 marks in part A alone. They're quite tricky. Things to trip up on is sort of normal integration. You might have integrated x wrong. You might have accidentally differentiated instead of integrated. Apparently that was a common mistake according to the examiner's report. People got their differentiation and integration mixed up in this sort of step, or they applied the formula wrong. And a common part that was wrong is this differentiating ln x squared to 2 ln x 1 over x, or 2 over x ln x. So make sure you know your rules. And that was 8 marks there. Let's get on to part B on the next whiteboard. Okay, so part B, using the substitution u equals root x, find the exact value of the integral between 4 and 1 of 1 over x plus root x dx. So it's told us what substitution to use, and so a first step would be to get this in terms of u. Okay, so we're going to be integrating, and it's going to become 1 over, now x is root x squared, so it's therefore going to be u squared, and root x is equal to u, so it's u. But at the minute it's still by dx. Now because it's getting in terms of u rather than x, we're changing these numbers here. So u equals root x, and because these values are for the x, if we root them, we'll therefore get it for the integrals of u. So root 1 is still 1, but root 4 is 2. So we're now integrating between the points 1 and 2 because we're now in u rather than x. But at the minute it's still in terms of dx, whereas we'd want it in terms of du, otherwise we can't do anything. So u equals root x, so du by dx, differentiating this root x from core 1, because x is to the half, we times by the half, a half x to the minus a half, which you should know is the same as a half times 1 over root x, or 1 over 2x, 2 root x. Now, if root x is u, then we can put that in there, so we've got du by dx equals 1 over 2u, because this root x is u. So we've got that. And we want to rearrange it to get dx, so we can exchange this dx for it in terms of du. So dx equals du over 1 over 2u, which is just 2u du. So we put that in here, we have the integral between the points 2 and 1 of 1 over u squared plus u. But now the dx we can change with 2u du. So we're integrating between the points 2 and 1, 2u over u squared plus u du. Now we can take the 2 out for a second. We can take it out, so it would be a half on the outside. No, sorry, apologies. Don't know why I said that. It would be a 2 on the outside, between the points 2 and 1. And so we'll just have u over u squared plus u, which can simplify to 1 over u plus 1 du. So we've got the 2 outside of some big square brackets. The integral of 1 over u plus u is ln u plus 1. So it's ln u plus 1. That's not a square bracket. Minus the other one. It's ln, and again it's u plus 1, but we're going to do it for these two different values between 2 and 1. So we're going to have 2 lots of ln. Now when u is 2, 2 plus 1 is 3, so it's 2 ln 3 minus 2 lots of, and when u is 1, u plus 1 is 2, so it's 2 lots of ln 2. And it says in the question it wants an exact value, and this is exact. If you put it in decimal, it is no longer exact. 2 ln 3 minus 2 ln 2 is an exact value. So altogether this question was worth 7 marks, making question 10 altogether worth 15 marks, which is a whopper. So what did we do, just to reiterate everything? Firstly, we put our equation with x's in terms of u's where we could, so we put our u in. Then we changed our limits on the integration in terms of u rather than in terms of x. Then we took our u and we differentiated it to get du dx and rearranged it to get what dx equals, which is 2u du, so we can put it into the equation and get the whole thing completely in terms of u. Because when you got it in terms of u, this particular example simplified, so we got it into that in terms of u, but when it's all in terms of u, you can integrate it. It doesn't make sense to integrate u with respect to x. Once you've integrated it, it's just your standard stuff you did in sort of core 1, core 2, you're just plonking numbers into it, one of them minus the other limit, but we're leaving it in an exact form, so it's like that rather than decimals. Hope this helped. That's the end of the June paper. It's now completed. Hope the entire thing helped, and I'll do another paper soon.